Okay, let's continue now to look at this one. I want to take this, show this one on the chart. So let's clear this one, create our line of charge. Let's make it a vertical line this time. Okay, looks like a pretty decent line of charge. Let's maybe we'll add a few more charges between, just make it more stronger. You get a nice continuous line. Quite a strong field this will be. Trying to make sure these guys are pretty straight at the end. And I can help this guy to make this go straight. Good. Another guy here to help it go straight at the end. Okay, good. So now I've basically got a nice straight electric field coming in. Okay, great. And let's quickly, okay. Now what's going to happen here, let's show the voltage, so it's all negative. Now let's take a little positive guy stuck here. He doesn't do too much. Okay, let's maybe make a cluster so that they can have a chance to actually do something. Here's my little cluster of positive charges. Wow, okay. Let's start to look at what our potential lines are going to be. You can see here we've got a high potential area and a low area. Negative, okay? So let's start to draw our potential lines. Well, 100 and let's do 150. Okay, great. Let's do 120. Let's do 90. Let's do 60. We're trying to do 30 each time now. Let's do 30. 30, 30, 30, 30, 30. Where are you, 30? Okay, maybe we're going to 34. Okay. All right, so there's a lot of stuff happening between there. Okay. Well, here's a 30 here I could do here. Let's try to do 0. Okay, there's a 0. All right, so what have we got over here? We've got minus 34, minus 60, minus 30, a 0 point, and a positive 30. Let's do a positive 62 so we get an idea there. Everything is correct. Okay, so we've got a little area here and a lot of negative stuff here. Okay, and there's very little effect of this way over here. Okay, so this gives us an idea. So what's our electric field going to look like? Well, way out here, you can see our electric field lines are going to be pretty well straight. In fact, this hot spot is not going to affect the electric field lines over here. However, along this area, we're going to start to see electric field lines turning and coming and ending at here. This part, electric field lines turning and coming to here. This way, a strong electric field coming across here. Electric field lines here, 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 and here. On this side, we're not going to see everything. Everything electric field lines not affected. Let's add some negative guys over here. A whole cluster of negative stuff. Little negative cluster here, just like I have my big positive cluster on that side. We'll put a negative cluster on this side. Okay, and we can see how our electric field vectors on this side are now turning to come in. So the ones coming here are going to turn to come here. So we've got some electric fields coming over here. They're coming pretty straight, but here they're starting to turn to end up here. Turning to end up here. It's kind of complicated, actually. But let's do a quick... okay, remember electric field vectors are going to have to go perpendicular to all these things. So drawing these, I'm not trying to do them equal distance now. I'm just trying to so I get an idea what things look like. Okay, again, so far away, it's pretty flat. Looks like a line charge. Close by, there's quite a bit of distribution. Here we've got a very deep negative hole. So we've got stuff coming in here. It's going to hit here. If I've got an electric field vector coming through here, it's going to probably turn into here. Electric field vectors here are going to start to come to here. Then they're going to start to turn away and go into here. These guys are going to, whoa, turn very sharply and into come into here. Okay, so there's a couple of line charges with positive and negative charges, how we're seeing how they look. Let's go back and see what else we want to do. Okay, I've looked at some positive charges, negative charge. These guys you'll be drawing. Now let's move on and try to do some actual devices. I want us to try to do it for a battery. Okay, you're going to just draw a battery. Okay. Let's work through this one together. How would I model a battery? Let's clear this stuff. Clear everything. For me, I would just model the battery as a negative charge and a positive charge. Okay, so inside the battery would be, this would be the inside the battery. This is a positive potential and a negative potential. We can, okay, there's our negative side and our positive side. It's basically a dipole. Okay, so what we're going to see is basically the electric field lines circling around on the outside and then coming through on the inside from the positive to the negative and then circling around the electric field lines. Our constant potential surfaces are going to be outside the, okay, are going to look sort of like this, and okay, this, just like the dipole, the constant potential surfaces. And we're going to have basically a zero potential line going straight down the middle, right? Just like before for the dipole. Okay. What's the next one we want to try to draw now? Remember to pause the video for each of these guys. The wire. I've connected a wire now to my battery. What's this going to do? How is it going to affect the electric field? This you're going to have to draw, and I'll give you a few minutes to try to work on that. So again, we pause the video. Okay, this time, for this one, you're not going to be able to use the simulation to try to work it. You're going to have to use your brain. Okay, sorry, I forgot to tell you that. This one, you need to use your brain, not your simulation. So the simulation is not going to be useful for this guy. Okay, we're just going to have to try to work on what we know. Okay, so let's go. I'm going to now try to draw it in my system. Okay, let's get rid of everything. Get my battery. Unlock, delete it, okay? Let's draw my little battery. Okay, maybe I'm gonna make my line. Line will be black. The fill will be cancel. So fill, I want to be, I don't want any fill. So no fill. Okay, great. No fill. Okay, great. So there's my battery. Okay, now I'm going to put my line, let's draw my line on it. Well, that's not a very good line, is it? Okay, that's ended. All right. Here's my battery. What do I know first of all? First of all, that all along the line, V equals plus, let's put our 0.75 volts. I'm going to assume now I'm going to put my okay. And on this one, V equals minus 0.75. Okay, that's my along the wire, right? The wire's attached to the battery. The battery is, we know that delta V equals 1.5 volts, right? For a battery. Okay, and let's make this, this should be, why does it keep doing that? I don't want this, I need to be UTF-8. Good, okay, I should be able to find Greek now. Somewhere down here. Not sure where it is. Okay, never mind. Okay, we'll forget that. Let's do, maybe we can go to symbol. I should be here, delta. Here we are. Good. And it should be 12. Okay, good. Okay, so delta V equals, okay, and we can probably rotate it. But actually, we don't need to worry about that. Delta V for my battery. Transformations. Rotate. 90. Apply. Okay, my battery with a delta V equals 1.5 volts. My upper wire is going to be 0.7 volts. My bottom wire is 0.07 volts. Okay? This is my basic system. Let's make it all black. Let's make this line also none. Okay, there's my battery. Good. Okay, let's lock it. Let's group it and then lock object. Okay. Let's now start to draw the potential lines on. Okay, I'm going to try to draw potential lines. Object properties. Okay, sorry, no. I don't want to be touching this logic. Line. I want my line to be just like, I'm going to want. Okay, good, and no arrows. It's a potential line, okay? I don't want to start with the electric field first. Okay, so let's draw my first potential line. So, assuming we're basically in the middle, I'm going to get a potential line coming straight through the middle. Oh, no. This is going to be 0 at right about here in the middle. We should have a 0 potential line coming straight through here. Okay, because there's going to be zero potential right in the middle of these two lines. This is 1 point high 0.75 volt. This is minus 0.7 volts. So we're going to have an electric field coming across, right? Going from the positive to the negative. But here it's very close. So the I'm going to basically, if I'm going to say, okay, if I'm going to have to draw this, it's going to be something like the positive voltage lines are going to be somewhere like along here. I'm going to get a line here. Potential drop, and I'm going to close it. On the other side, on the negative side, I'm going to have a similar thing. Clock, okay? All right, let's zoom in. Let's look at this electric field. I mean, the potential. From the potential difference, it's dropping 1.5 volts in this little narrow gap. Here is a long gap. So I'm going to start to get I'm going to have some electric field lines. Let's now draw some electric field lines. Okay, so we know it goes from positive to negative, right? It's going to go perpendicular to this and come back this way. Okay, let's get one electric field line. But actually, this is also positive, so we're going to actually have an electric field line coming this way. Since it's a long line, it's going to be somewhere like this in the middle. Come on, I want to get an electric field line here. So there should still be some sort of electric field line here. So these but here, let's move down to this little area now. We can see here, wow, this is very sharp. That means my electric field in this area is going to be very strong. Yeah, so basically the electric field is going to be at this very tip spot. It's going to be very, very strong. Okay? As they cross through and try to hit the wires. Okay? So this gives us an idea of this electric field in this sort of a shape. Okay. We're starting to get an idea why. So a capacitor, if I put a capacitor here, right, you know what's going to happen here. I'm going to have a large electric field in this area. Okay, next shape. That's the battery with the wire. We're going to start doing an antenna now. In this one, I want you to also draw the charges. The charge distribution. What happens to the charges in this case? Where do the charges go? Okay? That's the most important thing that you have to do first is the charges. I'll give you a few minutes to do that. What I'm going to do is, okay, we'll pause the video again. Okay, and the final one I want you to do is this complete circuit with an antenna with a DC attached to it. Okay, so this is our complete circuit. I want you to look at this guy now. Please try to solve it. Find where the charges are going to be and what charges are going to assemble on these AGs and how are they going to look like and what's the electric field going to look like. Okay, oops. Let's continue. Okay.